you through the physics course for the 11th standard, and then we will move on. So I'm assuming all of you have decided, and then you are going to write the JEE mains, and you are not wavering, as in partly going for this and partly going for that. So you have decided that you want to prepare for the JEE mains, right? So this JEE mains basically will be held for you, of course, 2022. It's far away, but yeah, so that is when you will be writing your exams. Now we have both 11th portions and the 12th portions in our exams. We will get 25 questions as a pattern today, 20 normal questions, MCQs, and 5 questions which are integer type questions. They are numericals. Okay, so we have to answer these questions. Yeah, so we have to answer this. Now, all the questions that you get in physics will be new questions, different from what you have seen. So you will need certain amount of application knowledge. You will need certain amount of application knowledge to answer those. And most importantly, you will need lot of focus. So please make sure that you are doing these. There is no group study in 11th. There cannot be any group study. There can only be individual study. And individually only you will be going and writing the exam. So make sure that you are working and make sure that you are trying your best. Then another thing that I want to tell you is that physics is one of the most difficult subjects. Difficult subjects basically because I feel that students don't spend adequate time. Basically, physics is a tough friend. To develop friendship, it takes time. Okay, it takes a lot of time to develop friendship, but once you develop friendship with physics, everything else will be cakewalk. Okay, so basically this is what we will be doing. My expectations from you is to write notes. My expectation from you is to understand that there will be no spoon feeding. Yes, my expectation is you will run with me. Initially there will be body pain, but in due course of time it will all be fine and you will enjoy it. Okay, so with a positive note, positive mind, let's try to work. The first chapter that I'll be doing with you is the basics of mathematics. Is the basics of mathematics. So let us see where it will take us, how it will take us. Let us see. Okay, so please write notes. I'll be giving you a lot of homework. I expect your homework to be done and messaged to this number. Okay, that is my number. So any doubts you have, message here. I won't look at the chats. Then again, homework has to be messaged here on a regular basis. Okay, fine. Now I hope all of you know about something called as a set. A set is a collection of well-defined objects. A set is a collection of well-defined objects. So here I have a collection of well-defined objects. I'll call this a set A. Here I have another set which is a collection of another set of well-defined objects. Okay, so these are two different sets. So this has well-defined objects and this also has well-defined objects. Now, just for the sake of it, I can try to relate these numbers. And what is the relation here? B is a square of. So that is a relation. We can have many kind of relations. B is equal to. B is greater than. B is less than. B into 2 is equal to A. B by 2 is equal to A. And like this, I can keep going on. There can be millions of relations. Do you understand this? I'm talking about one set which has elements 1, 2, 3, 4. It has just 4 elements. A set is basically a collection of well-defined objects. So I'm giving you an example of a set. There is a set B which is also a collection of well-defined objects, and I've given you an example of set B which is 1, 4, 9, 16 and so on. So you have a collection of well-defined objects here, and you have a collection of well-defined objects here. There can be some kind of a relation between them. In this particular case, the relation is B is a square of A, but otherwise there can be numerous kinds of relations. I have listed down a few of them here. Square is there, cube is there, quadruple is there, 5th power, 6th power, 7th power, go on up to a million. So you have so many different kinds of relations which are possible between A and B. In this case, A is said to be an independent set. And B is said to be the dependent set. So the dependent variable is related to the independent variable. So I could have said that y is equal to x square. Here y is dependent and x is independent. Because x is independent, whenever you give any value, you give a value to x. And once you give the value to x, you will get the value for y. Do you understand this? Such a expression is what is called a function. You have read this in polynomials in your 9th standard. P of x is equal to a x power n plus b x power n minus 1 plus c x power n minus 2 plus a0. So this for us is a function. So we will like to write f of x is equal to ax squared plus bx plus c. This is a quadrilateral, quadratic function. F of x is equal to ax plus b. This is a linear function. So if I want to have a quadratic function, if I want to have a linear function, then if I want to have a cubic function, so these are all examples of functions. Here, this is the same as y is equal to, this is the dependent variable, x is the independent variable. Here these are all algebraic expressions, so these are algebraic functions. These are all algebraic functions. Now suppose f of x is equal to ax square plus bx plus c. What is f of 2 equal to? What is f of 2 equal to? So f of 2 is simply a into 2 squared plus b into 2 plus c. That is equal to 4a plus 2b plus c. Hmm? 4a plus 2b plus c. Then f of minus 2 is equal to a minus 2 square plus b into minus 2 plus c. So that will give you 4a squared minus 2b plus c. Basically, a function is some kind of an equation which relates a dependent variable to an independent variable. So if I say y is equal to 1 by 1 plus x, so this is a function. Because this is some kind of a relationship between x and y, I can also write this as f of x. So when I say f of x, I mean to say something which is dependent on x. That something which is dependent on x is y. Y is equal to 1 by 1 plus x. Okay, so like this, I can think of 101, 1001, or 1,000,001 different types of functions. A function is nothing but a relationship between an x and y, which has certain criteria. We are not interested in that criteria. The maths people will tell you about that criteria whenever it comes in maths. But for us, there is a specific relationship between x and y. So we are more interested in that. So this is an algebraic relationship. Now I can have a trigonometric relationship also. Y is equal to tan squared of ax plus b. So these are all different relations. What we call it as function. So we are using the word function, which is a relation between a y and a x. Y is called the dependent variable, x is called the independent variable, and these are all members of two different sets which are well defined. Okay, this much is enough for us. The maths guys will tell you more details and try to bring you different concepts in it. Now we are going to talk about different kinds of relationships. One is an algebraic relationship. Then we are going to talk about a trigonometric we're going to talk about logarithmic. Then if time permits and if interest permits, we'll talk about exponential functions. Basically, y is equal to a power x. So y is equal to a power x is also an exponential function. X power a is also an exponential function. So y is equal to x squared, y is equal to x cubed, y is equal to x power n. All these are exponential functions. Or y is equal to a power x, more specifically exponential functions, y is equal to e power x, where e is one very nice beautiful number. Lot of maths that you're going to learn in your 11th and 12th will be very different from whatever you have seen till now. You might be thinking trigonometric function sin x, you might be thinking that x is an angle here. We are not talking about x as an angle. In fact, for us, sin x is nothing but x minus x cubed by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial and so on. Okay, so for us, maths has a very different meaning than what you have learned. Logarithmic is log of x and so on. Algebraic functions, you know. Okay, so let's talk about these a little bit more in detail. So first I'll talk about algebraic functions. We are not interested in that whole thing. We are interested in a few small aspects. So anything which looks like algebra, you know, suppose I say f of x is equal to 1 by 1 plus x. F of x is equal to 1 by x squared minus a squared. F of x is equal to ax squared plus bx plus c. F of x is equal to x squared. F of x is equal to 1 by x. So let's analyze these. Okay, now here we can also say y is equal to y is equal to y is equal to y is equal to. The moment you say this, you are saying that there is something which is dependent on x. Here you are saying that y is a function of x. That means y depends on the values of x. So they both mean the same thing. So whenever we have a function like this, we want to know where the function is defined, where the function is not defined. So where is the function defined and where is the function not defined? Now suppose I say y is equal to 1 by 1 plus x. Can you tell me what is f of 0? Very simple, 1 by 1 plus 0, so that is 1. So f of 0, you know how much it is. Now I am asking you, can you tell me what is f of minus 1? Yes, you'll say 1 by 1 minus 1, that is 1 by 0. But how much is 1 by 0? Not defined. So not defined. Yeah. Now can it happen? Is it that x is not defined for any other value? No, only at x is equal to minus 1 it is not defined. The values of x, the values of x for which it is defined is called the domain. These are names, standard, there is nothing else here. The values of x for which it is defined, for which means for which it is defined means who is that it, y is defined, is called the domain. That is the name given. So for the first one, the domain is that x is not equal to minus 1. Because if x is equal to minus 1, then this is not defined. So that is the domain. So what is the domain? The domain is, remember I asked you for 1000 questions in algebra, in calculus. Yeah, so these also come into that. Find the domain of a function. So the domain of an algebraic function. Domains are those values of x for which x is defined. For not x, y is defined. So I'll give you some more examples. So let's look at this. 1 by x square minus a square. Now 1 by x square minus a square, can I write it as 1 by x minus a into x plus a? Can I write it as 1 by x minus a into x plus a? So if I write it as 1 by x minus a into x plus a, then can I say that if x is equal to a, then y is equal to 1 by 0? So not defined. Then suppose x is equal to minus a, then this becomes 0. So again not defined. So if f of x is 1 by x square minus a squared, then x will belong to all real numbers minus those two numbers. Which are those two numbers? A and minus a. Always lower number first, higher number later. So it is set of all real numbers minus a comma a. Now this is the terminology that we want to learn how to read. So when we go for a book, there it is written like this, and this will actually create a lot of mental trouble for us if we don't know what it is. So let's go and let's treat this as a first question. F of x is equal to 1 by x squared minus a squared. Find the domain of the function. What do you mean by domain of the function? Domain means the values of x for which y is defined. What do you mean y is defined? I mean y exists. What do you mean y is exist? Y is not an indeterminate number. What is this indeterminate number? We have never come across indeterminate numbers. Yes, you have. 1 upon 0 is indeterminate. 0 upon 0 is indeterminate. E power 0, a power 0, anything power 0 is 1. We know, sorry. Anything power infinity is indeterminate. Okay, so like this we have several indeterminate numbers which we will come across slowly. Right now I'm saying that if f of x is equal to 1 by x square minus a squared, I can write it as x minus a into x plus a. I can write it as x minus a into x plus a. Then I know if x is a, it becomes 0. So all those values for which the denominator becomes 0, it is not defined. So x belongs to all real numbers minus those two numbers, minus a comma a. So this is the domain for the given function. This is the domain for the given function. What is the function? 1 by x square minus a square. Okay. So if f of x is equal to 1 by x plus a, then x belongs to R minus only one element, minus a. Okay. So the domain of a function refers to the values of x for which the function is defined. Okay, that is the domain. So if you can make some notes, we will move on. This is the basic basics. Okay, there is nothing more basic than this. Okay, so this is just a terminology. There is nothing else. So you have to convince yourself that there is some maths coming in, and that maths is talking about a variable. A variable means something which changes. So here y changes with x. So y is a function of x. How does it change? It changes based on x. So y is a function of x. We have already seen this when we read polynomials and all. We have seen this, though we would not have paid much attention at that time, but we have seen this kind of an idea. We already have this kind of an idea. Okay, so let's go to the next thing. So the next thing is we have to develop on this a little bit more. So suppose I say that f of x is equal to 1 by x plus a. Then you said the domain is x belongs to R minus this number minus a. Yeah. So that means f of y exists for all these numbers. Then I can also ask you for the range of the function. Range of the function. Range of the function is the values that y could take for the different values of x. The values that y could take for the different values of x. So that is the range of the function. Okay, so suppose y is equal to 1 by x plus a, then I can give x a value minus infinity. If I give a value x as minus infinity, y will become equal to what? Y will become equal to 1 by minus infinity plus a. So that is 1 by minus infinity, which is 0. Then I can also give, I can now increase the values of x. Suppose I give value of x is equal to minus a. If x is equal to minus a, then y is becoming what? 1 by 0, which will become infinity, which is not defined. That means this is my coordinate axis. Then at x is equal to minus infinity, I'm going towards 0. That means I'm going towards this, negative. Then as I am increasing the value of x, it is increasing. I'm little less than minus a. If I'm little less than I'm little less than minus a. So it is minus a plus something. So it is minus a plus something. So if it is minus of a plus something, I land up with 1 by minus of whatever that something is. So if that something is a very small number, so it will be a negative number, but it will be big. This is a minus a. At minus a, I don't know where it is. So I can't do anything with it. Then when x becomes a little more than minus a, now it will be minus a plus something. So it will now become plus. So now again it will start from here. And when x tends to this, it will go like this. So The range can be any number other than it can be any number. So if y is equal to 1 by x plus a, y can take all possible values. So you'll tell me, sir, how can y be a positive? How can y be a okay? You can ask me. Okay, can you think about it? I'll take little time to explain it. We are talking about the range of a function. Range of a function refers to the values that y will take for different values of x. Okay, now suppose x is a number like minus 10a, then y will become 1 by minus 10a plus a, that will become minus 1 by 9a. So whatever it is, that x will become a small number, negative number. Okay, now I want to understand, so x is a negative number, so x can take all possible values of do you understand this? So do you understand that the graph of this looks something like what I have drawn here? So to give you an example, suppose I have 1 by x plus 2. Suppose x is equal to 1.999 minus. So what will y become equal to? 1 by minus 1.999 plus 2. That is 1 by 0.001, which is equal to 1000. Suppose I say x is equal to 2.001 minus 2.001, then y will become equal to 1 by minus 2.001 plus 2. So that is minus 1 by 0.001. That means it will become equal to minus 1000. So I can give now any number. You can put any number of zeros here to get any number that you want. Yeah. So you want fractions. You want fraction means you take y is equal to minus 100. So y is equal to 1 by minus 100 plus 2. So that is minus 1 by 98. So you'll get a fraction. You take it as 12. 12 means you'll get 1 by 10. So whatever number you want, you can get. So here y will simply belong to R. That whatever number you want, you will get. How can I say that even in a much better manner? Now, can I say that x plus a is equal to 1 by y? Can I say x is equal to 1 by y minus a? Now, here I can find all values of x except one value. Which is that value? Y is equal to 0. Because when y is equal to 0, this whole thing is undefined. When y is equal to 0, this thing is undefined. So I will not get a value y is equal to 0. Other than y is equal to 0, I'll get every other value of y. So the domain for this function is the entire range of numbers. In that range of numbers, of course, when y becomes, for me to get y equal to 0, what should I get? What is the value of x for which y is 0? So if y is 0, this will become infinity. It's a huge number. So x tends to infinity. That is what we were seeing here. When x is going towards infinity, y will go and touch 0. But exactly 0 is not possible. So we can say minus 0. It will approach 0, but it will never touch 0. Okay. This was a slightly difficult question. I hope you are able to understand it. But if you're not able to understand it, don't worry about it. This is just the beginning. Okay. So domain and range. Domain is the value of x for which the function is defined. Range is the value of the dependent variable for the different values of the independent variable. Okay, this is the definition. Now you will have to think about it. Suppose I am saying y is equal to root over of x. What will be the domain for this? X belongs to R plus. Can you find out the root over of -3? You cannot. So x belongs to R plus. So the domain here is R plus. What is R? R is the set of all real numbers. What does plus mean? That we are taking the positive real numbers. So we are learning all these things to understand this terminology rather than to do domain range. Domain range they'll teach us in maths. It's probably the last chapter in your 11th syllabus. So they'll teach us in maths. But when we read our textbooks, our physics books, somewhere they will give x belongs to R plus. Excuse me. Somewhere they will give x belongs to R plus. So we need to know what R plus is. Okay. Now, in this case, I can say that x is equal to y squared. Yeah, if x is equal to y squared, then x is always positive because y squared for all values of y, x will only be positive, square is always positive. So we have to understand that. A square is always positive. So why did I say y is equal to root over of x? Y belongs to R. Y can be positive or negative. Because I know root over of 14 is root over of 16 is equal to +4 and -4. So y will belong to R, but x will belong only to R plus. Yeah. So here is the domain. Here is the range. Can you make some notes? We will talk about this at least for the next 2-3 classes. We'll keep talking about this. It will be a little difficult to understand. Not to worry. To keep trying more. Okay, so if you get it, we will take it slow. Don't worry about it. We're just talking about functions. Today's thing is we have learned something about a function. Now, many things. See, there are few more things that we would like to know. Whenever we write a function, our ultimate aim is to be able to draw a graph. So, I would like you to understand that if f of x is 1 by x plus a, the graph looks something like this. This is minus a. Less than minus a, it's negative, and it keeps going towards infinity. More than minus a, it becomes positive, and then it keeps going this way. So if you are able to understand this, my job is done. Okay. Now, whether you understand it logically, whether you give numbers and then understand it, whatever, it's up to you. So I can understand it. Suppose x is minus infinity, big number. So minus infinity plus a. So it is 1 by minus big number. 1 by minus big number will be minus 0. So I'm going towards minus 0. So this is the line. Okay. Then if x is tending to plus infinity, big number, then this will tend to 0. So there it is going. Now if x is tending to a, on a I don't know, because it is becoming infinity. Infinity is a very big number. Sorry, minus a. Infinity is a very big number. So if it is minus a, so in minus a I can think like this. Suppose it was x plus 2, then I can think of minus 1.9999 plus 2. I can think of 1 by minus 2.00001 plus 2. So when I do this, it's a negative number. When I do this, it's a positive number. And both the times it is becoming huge. So I drew this and I drew this. Yeah. And I also understand that this is a non-linear graph. Non-linear graph. So for every function, we want to draw a graph and then we want to understand. This is what is important for us. Okay. So we are talking of algebraic functions, and then we were talking of graphs. We were talking of functions first. Then we are talking of domain and range. Then we are talking of graphs. It will take us quite some time before we do these things. We are just begun today. It will take you 2-3 months before you do. That's why I put the 1,000 questions. If you work out 1,000 questions, you'll automatically be able to understand what we are saying. I said 1,000 questions. Einstein said 10,000 hours. So Einstein said for anybody to become a master in any subject, anything, if he spends 10,000 hours, he will become a master. So 10,000 hours means, suppose we spend 20 hours per day. 20 hours per day means we will need so many days, 500 days. Suppose we work for how many days per year will we work? So 20 hours is not feasible. So I think we will work for 2 hours per day or 2 hours per subject. So 10,000 by 2 hours per subject. So some of you may be working for 4 hours per subject. So if you're working for 2 hours per subject, you will need 5,000 days. Here it will become 2,500 days. Now, if you are working for 300 days per year, it will take you, my goodness, 16 years. Here, if you are working for same 300 days per year, you will do it in 8 years. But we want to do it in 2 years. So if you want to do it in 2 years means we want to do it in 600 days. No, we'll work for all days. So 700 days into 2 years. So 700 days into X hours will become equal to 10,000. So 0, 0 cancel, 0, 0 cancel. So 7, 1, 7, 30, 14 hours per day. But assume we are 50% more intelligent than Einstein. So if we work 7 hours per day, and if we are 2 times more intelligent than Einstein, in 2 years, we will crack it. Now you think whether you have time, how much time do you have to waste? How much time do you have to go play that online sport or play games on your videos or whatever, chat with your friends or do whatever? Now you decide. Now some of you may be 3 times more intelligent than Einstein. Even if you are 3 times more intelligent than Einstein, you still have to study 3 times. Now 3 times means you still have to study 5 hours per subject. And if you become great in physics, it's of no use. You have to become great in physics, you have to become great in chemistry, and you have to become great in maths. Okay, so this is primarily the mantra to get into a good institute. Consistent effort. Waking up one day and telling that today I will do 20 hours of work is not going to help you. Daily 3 hours, 4 hours of work per subject. Now you are sitting at home, you have to do that much, because it takes us a long time to understand. But once the human brain understands it, then it will be able to do things fast. But till it understands, we have to have that patience. Okay? Okay, good. So let's move on. So let me take another function for you. Y is equal to x plus a. Now, if I take y is equal to x plus a, this is a linear graph. So linear graphs are very simple to draw. What should I do? I should just say x is 0. If here is x is 0, if x is 0, y is equal to a, y is a. Then I should say y is 0, y is 0, x is equal to minus a, minus a. So I just join these two. No. Do you see anywhere where it is becoming infinity or undefined or something? No. So here x will belong to R, all real numbers. That is the domain. Then y will also belong to R. That is the range. So that's it, very simple. Linear functions are very simple. Now y is equal to a minus x. How will this look like? Y is equal to a minus x. How will this look like? Let me see. Coordinate axis. So x is 0. If x is 0, y is a. I fixed my point. Then y is 0. So if y is 0, x is a. So if y is 0, x is a. So now it looks like this. What is the difference between these two? This line has a positive slope. This line has a negative slope. This angle here is more than 90. This angle here is less than 90. Slope is the tangent theta, where theta is the angle the line makes with the positive direction of x-axis. You can't mug this up. If you mug it up, you'll forget it. But here, this is the positive direction of x-axis. This is the line. So this is the angle. This is the positive direction of x-axis. This is the line. So this is the angle. This angle is greater than 90. This angle is less than 90. So tan 90. Here tan more than 90. Tan less than 90, tan more than 90. So this is said to be having a positive slope. If this angle here is acute, it is positive slope. If this angle here is obtuse, it is having a negative slope. Okay, fine. We will continue. So we have just begun. We will do lots more. These things will not be available in books, so don't worry about it. Try to just write your notes. We won't need the whole of it. We will be learning all this at least 2 times in maths. Once in your 11th and once again in your 12th. So please don't worry about it. This part is slightly difficult. Just read your notes again. Ask for the recorded version of this will be available. Make sure that you are viewing that 2-3 times. Okay. So that is the only way. Slowly, silently, we will learn. Yeah. Rome is not built in a day. We just going to develop small things over whatever we have learned. Yeah. Okay. So I think I have done quite a bit today. I'll stop here.